and final learning objective in section 3.5 is to find the minimum sample size needed to estimate a population proportion at a desired level of confidence. A researcher wishes to estimate the percentage of adults who support abolishing the penny. How large a sample is needed in order to be 90% confident that the sample proportion will not differ from the true proportion by more than 4 percentage points. In order to do this calculation, we're going to need a z-critical value, a z-star value that we'll be using in our formula. 90% confidence is a common confidence level, and so we can use the value that's given on this little table here. This table can be found in many different places. It's in the lecture notes, it's in the textbook, and it's in the formula sheet that you can use on exams. The formula for computing the minimum sample size for estimating a proportion is also found on the formula sheet, and it is that n has to be greater than or equal to z star squared times p times 1 minus p over the margin of error squared. So our z star, which we get from this table for 90% confidence, is 1.65. I need to square that. I'm not given a value for the proportion, and so if I'm not given a value for the proportion, I'm going to use 0.5. And then 1 minus 0.5 over the margin of error. The margin of error is the farthest away I want to be in my estimate. So I do not want to differ from the true proportion by more than 4 percentage points. I'll write 4% as a decimal, 0.04, and I need that squared as well. This can be simplified as 1.65 squared times 0.25, because 0.5 times 1 minus 0.5 is 0.25. That simplified version is also found on the formula sheet and in the textbook and in the lecture notes. So let's do this calculation. I'm going to bring up a GeoGebra calculator, and I'm going to input 1.65, and I need to square that, times 0.25, and then divided by 0.04, which also has to be squared. And that gives me 425.39. Now this formula gives us the minimum sample size that's required. So we need to be at least as big as 425.39. But sample size has to be a whole number. I can't find 0.39 of an adult to ask them how they feel about abolishing the penny. So if I round down to 425, I'm below my minimum, which means I'm too small. So instead, I'm going to round up to 426. Let's do another example. How many students must be surveyed if we want to estimate the percentage that belong to an on-campus club? Assume that we want 98% confidence that the estimate is within 2%. Suppose we know that last year, 28% of students belonged to an on-campus club. All right, so I'm going to use my same formula, and I know that n has to be greater than or equal to. Now for 98% confidence, I can see that the z-star value I'm going to use is 2.33 from my table. I'm going to square it. And now I am going to use the value for p because they gave us 28% from last year. So I'll use 0.28 times 1 minus 0.28. And then I'll divide by the margin of error. That's 2%. That's how close I want to be within. I'll write it as a decimal and I'll square it. And I will use GeoGebra again to calculate this. So my critical value was 2.33. Delete this one. 2.33 squared. And then I'm going to multiply times 0.28 times 1 minus 0.28. And then I'm going to divide by 0.02 squared, and that gives me 2,736.17. 2,736.17, and again I need to round up, so my answer becomes 2,737 as the sample size needed in order to estimate the percentage that belong to an on-campus club.